Welcome to this A-Level Chemistry exam question walkthrough. Feel free to download the questions from the link in the description below and have a go at them yourselves. Then you could watch this video afterwards to see how you got on. Kw is the dissociation constant for water and it is equal to the hydrogen ion concentration multiplied by the hydroxide ion concentration. At 25 degrees, the Kw value has a value of 1 times 10 to the minus 14 moles squared dm minus 6. In pure water, the hydrogen ion concentration is equal to the hydroxide ion concentration. Kw is often used to calculate the pH of strong bases. If we look at this first question, we're given a concentration for a solution of strontium hydroxide. Anything with a hydroxide in is classed as a strong base, so we can use Kw, and it says at 10 degrees Kw is equal to 2.93 times 10 to the minus 15. So at different temperatures Kw does vary. The first thing we're going to do is write out the expression for Kw. So Kw equals the concentration of the hydrogen ions times by the concentration of hydroxide ions. Then we want to rearrange this expression in terms of H+, from which we can find pH eventually. Now we're going to use the Kw, which is at 10 degrees that it's given us in the question. And the hydroxide ion concentration we need to times by 2, because the formula of strontium hydroxide, there are 2 formula units of the hydroxide ion. Because strontium is a group 2 metal, it forms a 2+ ion, meaning we need 2 of the hydroxide ions to balance. So after we've done Kw over the hydroxide ion concentration multiplied by 2, we get this value, and that's our second mark. That gives us our hydrogen ion concentration, and then we minus log this to get pH. And we know this must be a sensible value because it is a strong base, so it must have a pH between 12 and 14. For this next question, it's asking us why the concentration of water is not shown in the Kw expression. So why are the ions shown but not the water, which is the reactant? When writing equilibrium expressions like these, the concentration of pure liquids like water are considered constant and therefore not included. Only concentrations of reactants and products that can significantly change are included in these expressions. And the mark scheme is looking for the fact that the water is in excess, so its concentration is very large in comparison to those of the ions. In this next question, we're given a table of data and we're asked to explain why Kw changes with temperature. Specifically, why does it increase as temperature increases? To answer this, we'll need to think back to equilibria and Le Chatelier's principle. You might have noticed at the top of this question there was a positive enthalpy change value. That's telling us that this reaction is endothermic. And Le Chatelier's principle predicts that any increase in temperature will shift the position of equilibrium to the right in an endothermic reaction in order to minimize the effect of the temperature increase. The first part of this next question is asking us for the expression for pH. And this is always minus log of the concentration of hydrogen ions. The next part of the question wants us to calculate the pH of pure water at 50 degrees. And to do this, we'll need the Kw value for 50 degrees from the previous table, which was 5.48 times 10 to the minus 14. Notice it says pure water. In pure water, the concentration of hydrogen ions are equal to the concentration of hydroxide ions. So to get the hydrogen ion concentration and ultimately the pH, we can square root that Kw value, and that will give us the concentration of the hydrogen ions. We then minus log our answer, and that will give us the pH. For the last part of the question, we have to explain why pure water is neutral at 50 degrees. And anytime you're asked a question like this to do with pure water, it's because the concentration of the hydrogen ions are equal to the concentration of the hydroxide ions. This next question is a little bit different. Here we've got an excess of a strong base, sodium hydroxide, being added to a strong acid, hydrochloric acid. So since we've got a strong base in excess being added, that means that we'll finish up at a high alkaline pH. So something between maybe 12 and 14. So we're going to use Kw for this. The first thing we need to do, we've got 2 bits of information about the strong base and the strong acid, so we'll calculate moles of each of these by using concentration times volume, remembering to convert your volumes into decimeters cubed. Then some of that sodium hydroxide will be used up in the reaction, so some of it's going to react with the acid. We need to find the amount of sodium hydroxide that's left over, and to do this we simply subtract those moles. After we've got the moles of the hydroxide left over after reaction, we want to take into account the new total volume, so after the strong acid and strong base have been combined. To do that, we add the volumes, and then we can use that to work out the new hydroxide ion concentration, which we're going to plug into our Kw expression. So remember, concentration is moles over volume. We'll use the moles we just worked out, so the remaining hydroxide, over the new total volume, which is in decimeters cubed, and that means our concentration will come out in moles per decimeter cubed. There's a mistake in the unit there. I've put moles, it's meant to be moles per decimeter cubed for hydroxide concentration. Then we can work out the concentration of H+ by using the Kw constant over the hydroxide ion concentration we've just worked out, and then we can minus log that to find the pH. With this question, it's asking about pure water at 40 degrees. The pH is 6.67. A student thought the water was acidic, probably because it's slightly below pH 7. Explain why the student was incorrect. So anytime you see pure water, that means it's neutral, no matter if the pH isn't exactly 7. And that's because in pure water, the concentration of hydrogen ions is equal to the concentration of hydroxide ions, and that's what neutral means. Now the question is asking us to work out a value for Kw at this temperature. So remember, Kw changes, it varies with temperature. And to do that, we need to work out a hydrogen ion concentration. How do we do that? We can find the hydrogen ion concentration from the pH by doing 10 to the minus of the pH value. And then since H+ is equal to OH- concentration, we can just do the hydrogen ion concentration squared to get the value of Kw. This next question is worth 6 marks. So it says a strong acid, hydrochloric acid, is added to a strong alkali, barium hydroxide. And if you look at the concentration and volume values, you'll see that the barium hydroxide is in excess. So the resulting pH is going to end up being quite alkaline, which means we're going to use Kw. So we start with the things that we have 2 bits of information about, which is the acid and the alkali. So we've got concentration and volume for both, which means we can work out the moles of both of those by doing concentration times volume in decimeters cubed. Now there's an extra step with the moles of barium hydroxide, because if we look at the formula, there's 2 formula units of the hydroxide ion. So that means we have to times the moles of the hydroxide, so the moles of the barium hydroxide, by 2 to get the moles of the hydroxide ion within that. Next step is that we want to find the moles of hydroxide remaining after reaction, and to get that we do the moles of the hydroxide we just worked out, take away the moles of the acid and see what's left. After we've got moles of hydroxide ions remaining, we can work out the concentration of hydroxide by using those moles over the total volume of solution. After that, we can work out the hydrogen ion concentration using the Kw expression. So I've rearranged it in terms of H+. So we use the Kw constant that is given to us, so that's the value for 30 degrees Celsius, divide it by the OH- concentration we've just worked out. That gives us a H+ concentration, which we can then minus log to get a pH value. For this next one, it's just asking us which is the correct expression for Kw, and it's the one with the concentrations of hydrogen and hydroxide ions multiplied together. Water isn't included in the Kw expression because its concentration remains virtually unchanged. The expression is simplified without the need to include another constant. And since Kw is a type of equilibrium constant, remember, typically we don't include any pure liquids such as water. Calculate the pH of pure water at 10 degrees, give your answer to 2 decimal places. Remember, since it's pure water, the hydrogen ion concentration is equal to the hydroxide ion concentration. So to find H+, in order to find pH, we can just square root the Kw value given, which is at the top on the previous question. And this gives us a value of 7.27. Last question, well done if you've stayed around this long. So it says, suggest why pure water at 10 degrees is not alkaline. Anytime you see pure water, it's completely neutral because pure water means that the concentration of H+ is equal to the concentration of OH-. And that's considered neutral regardless of the pH value. Any questions? Just comment down below.